Chapter 9.5 really is a review of what you should have had in high school, or if you took Basic Math 1, what you had in Basic Math 1. What we're talking about here are right triangles and the Pythagorean theorem, which a Greek mathematician by the name of Pythagoras figured out that if you have a right triangle, that the hypotenuse of that right triangle is the longest side, and it sits opposite the right angle, which in our graph here, our picture, is designated by that little black square in the lower left corner. And what he discovered was, if you took that hypotenuse and then you squared it, that would be equal to leg number 1 squared plus leg number 2 squared. So you see the two legs are designated in blue, and then the hypotenuse is in red because it's special. Of course, writing hypotenuse squared equals leg squared plus leg squared really is kind of cumbersome. So what he did was he changed, and instead of using words, he used letters. The hypotenuse, it's critically important that you know that the hypotenuse is side C. The legs are designated as A and B, and it doesn't really matter which one you label as A and which one you label as B. So you can flip those around. We'll label this one A, and we'll label this one B. So now, instead of having a hypotenuse squared equals leg squared plus leg squared, what we end up with is the formula C squared equals A squared plus B squared. All right? Now, what we want, however, is not C squared. What we really want to know is how long is that side C. And so what we do is we can take now the square root of C squared equals the square root of A squared plus B squared. Now, the square root of a perfect square happens to be the letter itself. So that's C equals the square root of that whole quantity, A squared plus B squared. It is not this square root of A squared plus the square root of B squared. You would get something completely different if you tried that. So that's not what you're supposed to do. It's this whole thing. And if you want to take a look on page number 675, you'll see how he derived that formula. So now what I'm going to do is I'm going to rewrite that at the top. And that's our basic formula for figuring out the hypotenuse. I'll erase all this stuff having to do with the hypotenuse and all that kind of stuff. All right, so our basic formula is C equals the square root of A squared plus B squared. Now, it also happens that if you happen to be given the hypotenuse and you want to figure out a leg, you're going to need another formula. So what we do is we take our original C squared equals A squared plus B squared, and knowing the basic rules of algebra, what we're going to do now is we're going to subtract one of the two sides. In this particular case, what we're going to do is subtract B squared from both sides. Now what I get is C squared minus B squared equals A squared. So I've isolated the A side, and now if I take the square root of C squared minus B squared, I'll take the square root of A squared, or square root of C squared minus B squared is equal to A. And so the second formula that we use is A equals the square root of C squared minus B squared. Now, it doesn't really matter which side you call A, whether it's the vertical side or the horizontal side in our right triangle that we have depicted here on the right. But if you want to find out the length of one leg and you have the hypotenuse and the other leg, then you want to use that second formula. So now we've derived both formulas. Let's go ahead and take a look at some problems that are on page 678. And I want you to take a look at 679 where they talk about these 2 points. Because we haven't done the graphing that goes with those 2 points yet, then we're going to avoid those problems, and we're going to focus on the problems on page 678. Looking first at problem number 2, you see a right triangle there, and I'm not going to draw it again. But if you take a look, you'll see that there's an X. That side with the X in problem number 2, that's on 678, that side X happens to be across from the right angle. It also happens to be the longest side. Now that right triangle is drawn differently from ours, but you'll notice that the hypotenuse is the side that's opposite our right angle, just as it is in number 2. When you see that, what you know now is you want to use the formula for finding the hypotenuse, which is c equals the square root of a squared plus b squared. Now, that being the case, in number 2, a we'll say is 12, so it's the square root of 12 squared, and b happens to be 5, so that's 5 squared. Then when you do this, you get the square root of 144 plus 25. This then becomes the square root of 169. That's one of those perfect squares that we talked about. And so what you'll have is c equals 13. Now when I give problems, I usually use some measure of distance. So you might see inches, you might see meters, you might see miles. I don't like just plain numbers. But we have now done number 2. We're going to go ahead and do number 4. And the reason for that is with number 4, you'll take a look and you'll see that that side that's opposite the right angle is actually given to you. That happens to be 10. So what we're looking for now with x happens to be one of the 2 legs. That being the case, the equation we have to use now, or the formula, is a equals the square root of c squared minus b squared. So substituting in, a equals the square root of 10 squared minus 8 squared. A then equals the square root of 100 minus 64. A equals the square root of 36, and as you recall, that's a perfect square, so a equals 6. Now, there is a famous 3, 4, 5 right triangle, and any multiple of 3, 4, 5 you can figure out. So if one side's 3, the other side's 4, the hypotenuse is 5. In this case, if you multiply that by 2, you'll get 6, 8, and 10. So that's just one that you might want to keep in mind. What we want to look at now is a couple of the other problems that are on page 678. It says in number 8, I'm going to go back to the top of the page. What we're going to have to do now is sort of draw something. So we're going to look at problem number 8. Probably shouldn't have wiped out our formulas, but you've got those now. In fact, I'll rewrite those again. C equals the square root of a squared plus b squared, and a equals the square root of c squared minus b squared. So they're up there. It says, find the diagonal of a rectangle with 5-inch width and 7-inch length. So what we would do for number 8 is we actually draw a rectangle. And I'm just freehanding this. And then you say, what about the diagonal? So we just take and draw a little diagonal across. Now that's a rectangle. So you're saying, well, I don't get this because we've been working with triangles. Well, the diagonal of a rectangle forms a triangle if, in your imagination, you just erase two of the sides. So if we just erase this side and we just erase that side of a rectangle, what we end up with then is our right triangle. And our right angle is here. And now it says the width is 5, the length is 7. So we can see that what we're looking for is C equals the square root of a squared plus b squared. C equals the square root of 7 squared plus 5 squared. That's what I chose to do. Doesn't matter which one you choose. It could have been 5 squared plus 7 squared. Square root of 49 plus 25. Or C equals the square root of 74. Now, if you found that there was some perfect square that divided evenly into 74, you could go ahead and use that. But even if I use 4 divides into 74 not evenly. So I can't use that. What I need to do then is I need to get a hold of my calculator, punch in 74, and then hit the square root button. And what I'll get is 8.602. And we'll say that was inches, wasn't it? Yep, we got a label for that one. So, in some cases, that's all you have left in the way of resolving that problem. Let's drop down now to number 12. I'm going to erase number 8. We're going to keep our formulas up there. And now in number 12, what we have is a story problem involving a ladder. It says the base of a 15-foot ladder is 5 feet away from the wall. How high from the ground is the top of the ladder? In this particular case, I'm going to draw a picture, and what I've got is a wall. It looks like this. There's a wall. And then we have the base, which is the ground. Okay. And then we have our ladder, and our ladder sort of sits like this. So that's our ladder, and we know that's 15 feet. And it's 5 feet away from the wall, so this is 5 feet. Once I draw that, now I know this is our right angle right here, and opposite that right angle is 15. So in solving this, now I have to go to my second formula, which is A equals the square root of C squared minus B squared. And A equals the square root of 15 squared minus 5 squared. Therefore, A equals the square root of 225 minus 25. And therefore, A equals the square root of 200. Now, in this particular case, I can rationalize that by saying that's the same thing as the square root of 100 times the square root of 2, or that's 10 times the square root of 2. And if you punched in the square root of 2 and then multiplied it by 10, what you'd come out with is 14.142 feet. But there, if they wanted you, instead of giving a decimal answer, they wanted you to rationalize that square root of 200, you could say it's 10 times the square root of 2. We'll take a look at one more, and that happens to be problem number 16, I'm sorry. Problem number 16 has to do with a roof. So what we do is we draw a picture of a roof, and it kind of looks like this. That's our little roof there, okay? And it says in this, for the home described in exercise 15, if the roof is 7 meters from the peak, okay, from the peak to the eave, okay, from the peak up here to the eave down here is 7 meters. And then the attic space is 3 meters high at the peak. So here's the peak, and this happens to be 3 meters. It says how long does each of the pieces of insulation need to be. That insulation sits along here, okay? So what they're trying to figure out is how long does each one of those have to be. Now, if you recall, this will give us this part right here, okay? It gives us, when we do the work, what we're figuring out is this. But I'm assuming what they're really talking about is this entire distance across, okay? That should be equal. It doesn't look equal, but what we have now is our right angle here, and opposite that right angle we have 7 meters. So we know now we have to use that formula A equals the square root of c squared minus b squared, because we're trying to figure out this leg that sits right down in here. That's the leg we're looking for. So A equals the square root of 7 squared minus 3 squared. The math in this is not that difficult. 49 minus 9. A equals square root of 40. All right? And it so happens that a perfect square that divides evenly into 40 happens to be the square root of 4 times the square root of 10, or 2 times the square root of 10. Okay, so that should be about 6. All right? When you figure that out, you'll get an answer of 6 point something, say 6.3. But that's only this portion over here. That's only this part. We want insulation for the entire roof, so what we have to do is take this. So in our answer, once we've figured out the first section, we have to double it. So we have to multiply it by 2, and that then becomes 4 times the square root of 10. And so there you go. That'll be your answer. 4 times the square root of 10. Take the square root of 10 and then multiply it by 4, and my guess is you'll get an answer that's very close to the answer they have in the book, which is 12.6.